morning, students. We are discussing your third chapter, that is electrochemistry, and today we are going to discuss about measurement of cell potential, that is E cell. So how E cell is measured or calculated, or standard cell potential means E standard cell. So first we have to know what is cell potential or standard cell potential, means E cell or E standard cell. So already we have discussed about the cell potential or standard cell potential. So cell potential, that is the potential difference between cathode and anode. So you see here the potential difference between the two electrodes of a galvanic cell, that is electrochemical cell, is called the cell potential and is measured in volts. The cell potential is the difference between the electrode potential, that is reduction electrode potential of the cathode and anode. So the potential difference between the cathode and anode, that is called as the cell potential, and it is also called as the electromotive force EMF of the cell when no current is drawn through the cell. So it is now an accepted convention that we always keep the anode on the left hand side and cathode on the right while representing the galvanic cell. That already we have discussed, that whenever we represent a galvanic cell, always the anode is kept in the left hand side and cathode is kept in the right hand side. So a galvanic cell is generally represented by putting a vertical line between metal and electrolyte. There is a potential difference between the metal and electrolyte, that is called electropotential, and that is indicated by writing metal and the electrolyte, and they separated by a one vertical line, and putting a double vertical line between the two electrolytes concentration, we represent the cell. That means in a cell always two halves are there, one is the anode and cathode. This anode and cathode, they are separated by a two vertical line. So already we have seen also the cell representation. Say for example, if we see here, this is the chemical reaction for the cell. So copper plus 2 silver ion, and it gives copper 2 plus and 2 silver atom. So that means here copper is oxidized and silver ion is reduced. So this is your oxidation half, means copper is oxidized to copper 2 plus, that is your oxidation half. Anode, at anode that is taking place, copper convert to that of the copper 2 plus, releasing the electron, and at the cathode the reduction half is taking place, that means the silver ion that is reduced to silver by gaining that electron. So these are the two half reaction in this cell, and that cell is represented like that. You see here that how the cell is represented, that always we put or we keep the cathode in the anode in the left hand side and cathode in the right hand side. So that means here copper that is oxidized to copper 2 plus, so that is the anode, so that is kept in the left hand side, and that is separated by two vertical line, and then this is the cathode, silver ion that is reduced to that of the silver. So here what will be the E cell now? That E cell, that is E right minus E left, means E cathode minus E anode. So this way we calculate or measure the E cell. So this is the measurement of the E cell, that is E cell is equal to E right minus E left. So now if we take or if you consider the standard cell potential, then what happened, that whenever the electrolytes are at unit concentration, that means the concentration of the electrolytes are unity, then we call that cell potential as a standard cell potential. So that is denoted by E standard cell, like that. So the cell potential at standard conditions can be found through its equation E standard cell equal to E standard reduction, that means that is taking place at cathode, minus E standard anode, that is also a reduction electrode potential. So already I told you also that whenever we have to measure the standard or the cell potential, standard cell potential or a cell potential, then always we consider the reduction electrode potential. So already at the cathode reduction reaction is taking place, so that value will be coming out as a positive. But at the anode, since oxidation reaction is taking place, to have the reduction electrode potential, we have to put on negative sign. So this negative and the negative value of the reduction electron potential at the anode, that will be as a whole coming out positive. So ultimately we will get the standard E cell, that will be positive, and always cell potential will be positive. So this way we measure the standard cell potential. Now considering one example of a galvanic cell. So see here, this is the galvanic cell. Here these are the cell reactions. So this side, that is your anode, that means the oxidation is taking place, oxidation of zinc to that of the zinc 2 plus ion, that is taking place. Similarly in the right hand side, the reduction, that is the cathode, reduction is taking place. Here copper 2 plus, that is reduced to that of the copper. So this is the cell reaction, that means zinc, it is oxidized to that of the zinc 2 plus, and by the time copper 2 plus, it is reduced to that of the copper. So in this case, how will you find out the cell potential or standard cell potential? So for this oxidation, whatever the reduction electrode potential, that is minus 0.76. So that value is already assigned, so it is already calculated. And how to measure the standard electrode potential, in the next class we will discuss. So the standard electrode potential for the zinc rod, means zinc electrode, that is 0.76. Since here it is a oxidation half, so to have the reduction electrode potential, you have to put one negative sign. That means the reduction electrode potential for the zinc electrode here, that is your minus 0.76 volt. And similarly for the reduction reaction, so at the cathode, if you see that in the here it is the cathode, copper 2 plus, it is reduced to that of the copper. So at the cathode, E standard reduction, that will be equal to 0.34 volt. So these are the two electrode potential value for these two electrode, so that already measured. Now from this value we can find out the standard electrode potential, standard cell potential or E standard cell. So what will be this? That standard cell potential, E standard cell, that is equal to E standard cathode minus E standard anode, and in both the cases these are the reduction electrode potential. So their value, if you put that E standard cathode, in this case that is 0.34 volt, and E standard anode, in this case that value is minus 0.76. So already one minus sign is there, so minus minus plus, so ultimately it will come out to 1.1 volt. So this is the cell potential for this electrochemical cell. So this way we can find out the cell potential. So cell potential, simply we have to remember this relation, that if it is the standard solution, then standard cell potential will get E standard cell, so that is equal to E standard cathode minus E standard anode. That means E standard right minus E standard left. So this way we can find out the cell potential or standard cell potential. So thank you for today. In the next class we will discuss how to measure the standard hydrogen electrode. Okay, how to measure the standard electrode potential. Okay, thank you.